Hello everyone, my name is Chinada Chikonike and I'm a software engineer. And in this presentation, I'm going to be taking us on the topic anatomy of an AI agent, how autonomous systems learn to think and act. Before we delve into the components of AI agent and its anatomy, I first of all want to actually describe what an AI agent actually is. An AI agent is an autonomous system that makes decisions and takes actions to achieve a specific goals. So an AI agent, it perceives, it acts, it adapts, it is goal driven, it's accustomed to the particular situation at hand, and it actually gets feedback and acts based on that feedback it's gotten. And I would just like us to actually look at the differences between AI agents and traditional AI, as opposed to the traditional AI that we are used to, whereby you're getting prompts, and for each of those prompts, you're getting a response based on the prompts you're getting and on the prompts that it is actually given. Compared to those traditional ways or the traditional AI, AI agents are adaptive, they're autonomous, and they're goal driven. They adapt to the particular situation that is at hand, and it accustoms to that situation, and it iterates and like a feedback loop. So it goes through that process, gets feedback on its own, and it actually adapts to that. It's autonomous and it's goal driven. And and let's look at the high level anatomy of an AI agent, the core components. What exactly is the AI agent made up of? So the core components of an AI agent includes its environment, that is the things that are outside of that agent. The sensors, the decision making, which is like the a box whereby it has like policies and functions that it can actually use to make decisions. There are actuators. Actuators are more like actions. And then there are like learning mechanisms, and then there's memory. And first, we'll just look at the environment. The environment is everything that is external to that agent, the things that are outside of it. So the types of environments that we can see are the fully and partially observable environments. There are deterministic and stochastic environments. There are also static and dynamic environments. And lastly, there's like discrete and continuous environments. So examples of these environments that you see are like the chessboards, the financial market, and you talk about the road traffic as well. And let's move on to sensors. Sensors are they allow agents to observe the environment. So they more or less are used to perceive the environment. They're like perception layers. You can call them perception layers. They're used to actually perceive the environment around them. So in as much as they're in those environments which are like external, but to be able to work in those environments, they need to perceive the environment. They need to see the road traffic, for example. They need to get inputs. So examples of these would be like cameras, microphones. You have like logs and APIs. They can also sense using like databases. They can get inputs using databases or text inputs rather. So these are used to actually help the agent to view the environment, to perceive the environment, to be able to actually act on those environments. And speaking of acting on those environments, we'll be going into actuators. Actuators are like they're the components that help the AI agents to affect the environment. So they're like the action layers. So it helps the AI agents. The AI agent kind of like uses the sensors to act in those environments. So the actuators are the components um, that enable the agent to affect the environment. You're talking about steering wheels and braking cars. You're talking about API calls and automation. You're talking about like text and speech responses. And that would actually lead us to, so when it has all of these, the environment, it has the actuators and it has the sensors, it would use these are like data, right? So these are data for it to actually use this to make useful or make use of it. It will need to make decisions, and this brings us to the decision part of the AI agents. So we're talking about the decision functions and then the policies. So with these two, the AI agent can actually make um, crucial decisions and important decisions, or even minor decisions, to be able to work with those data that it has. So it actually has its environment where it's at. It has the perceptors, which is like the sensory nodes, and it also has actuators, which it can use to make useful action on the environments that it's within. And let's take a deep dive into policies. Now, policies are used to map state actions. So it's more like a guiding force for the agents to make core decisions or to make decisions. So you can see policies that are rule-based. You can also see policies that are probabilistic. And the most common ones that I've been actually seeing is like the learned policies, like when you're talking about the neural networks. So these help to guide the decision making of the AI agent, and would actually like to look at the learning mechanisms, because when it has these data and is able to make decisions, it can learn from the decisions that it's made. It can actually go ahead to make more decisions that are either supervised or unsupervised. So that would lead us to the learning mechanism. So learning allows the agents to adapt to new situations, to improve performance, and also handle uncertainty. And when you're talking about the learning paradigms, you're talking about the supervised learning, you're talking about unsupervised learning and reinforcement learning. So for reinforcement learning, the agent learns by trial and error. So it kind of tries something and then it doesn't work. It goes back and it tries it again. So it keeps doing this until it actually reinforces the things that it's trying to learn. So that would actually help the agents to learn based on what it's done previously, what worked, what didn't, and then it can build on that. And most models or modern models work with these three paradigms. Is they combine the three basically to be able to build um, more robust models. Use the three paradigms basically. Yeah. So we'll talk about memory in AI agents. So memory enables continuity and intelligence. There are different types of memory. You're talking the short-term memory, the long-term memory. There's episodic memory. There's also semantic memory. And these memory helps to actually keep previous conversations intact. You're talking like 10 minutes, 15 minutes, or previous conversations you had like 24 hours ago or thereabout. So it helps to actually keep the whole conversation flowing and not to have like gaps in discussions, and when they have memory, it's actually easier for them to learn and to reinforce what they've actually worked on previously and not have to start over. Um, there are some advantages, a lot of advantages when you talk about AI agents. It helps with efficiency and and effective use of systems, making systems much more easier and much more efficient for people to actually use. AI agents have been used in customer service in order to improve the service given to customers and to improve the quality of service that is given to customers. And there are AI agents in autonomous vehicles, self-driving cars, and the rest of them. And these aid in various ways that you can actually count. But in as much as there are like advantages, there are also disadvantages. There are ethical concerns, safety, alignment. What is the cons of this? There are these concerns are quite they're they're quite normal, and I believe there are more or less like a way for people to say, is this actually safe for us to use? How well can we actually know that the feedback loop is efficient? How well can we know? How well are the actions? Is it unintended? Are there unintended actions? Are there bias and fairness? And in terms of control, how well can we control this? Is this something that we can actually control, or is this something that can work on its own and is out of our control? What are the mitigating factors, and um how are these things being worked on? And these ethical concerns are quite they're these are actually a few of them. There is a lot of ethical concerns when it comes to AI agents, and there are also solutions that are being worked on to solve these whole ethical concerns. So solutions such as alignment techniques and constraint-based learning, and a lot more solutions which are being introduced to address these ethical concerns that are arising day to day. And and as these are actually being worked on, there are real world applications of agentic AIs, or AI agents rather. We have the autonomous vehicles, robotics. AI agents are being used in healthcare for optimization of the quality of health that is being rendered. You're talking about AI agents in finance and trading, and AI agents in virtual assistants and customer service, as earlier mentioned. And these agents are really um, are being incorporated in our day to day, and in being incorporated in various softwares and various um, aspects of the industry and various industries, and these help to actually make things a whole lot efficient, and address a lot of things that would normally require a lot of work and a lot of time and a lot of resources. And um, when you understand how these agents learn to think and act, it's quite essential in this day in terms of building smarter systems, deploying them safely, deploying the system safely, and harnessing their potential responsibly. And that brings us to the end of this presentation. I hope you enjoyed it. I hope you learned something from it. And in the spirit of Christmas and holidays, enjoy the rest of your holidays. Thank you.